Hi again. So let's look at algorithms and what they are. So an algorithm is any well-defined sequence of steps that you need to do in order to complete a specific task or make something. So for example, sort a list of numbers, or find the average of two student scores, or automatically park a car, or even normal things in daily life like making a paella valenciana. So let's look at the last one. How does it look? How does an algorithm look to make a paella valenciana? Here you see on this slide in the boxes the ingredients, the things that you need to make it. So these are the input to our algorithms. And you see a flow diagram that explains step by step how to make this desired paella. So you see that you put the ingredients, you make the oil hot, but try not to make it smoke. And then you put the meat, you put all the vegetables and the tomatoes. And when everything is put together, you add the water. Then you wait a little bit, you stir everything around, add the rice, and within 10 to 18 minutes, you've got a delicious paella. So this is a specific algorithm that step by step explains how to go to a specific task that you want to complete. In computer science, we write these things down in computer programs. So here you see an example of a Java program that calculates the average of two student scores. So you can see that we've got input two scores, score 1 and score 2. And what we do in order to calculate the average, we first define two variables, one total and one average, and we use these variables to calculate the average. So first we add the two scores together, score 1 plus score 2, and we store the result in the variable total. Then we take this total, divide it by 2 to get the average, and store this result in the variable average. And then we return the average because that's what we desire to do. So here you see an algorithm written down in a high-level programming language called Java to calculate the average of two scores. So how do we write an algorithm to solve a problem? How do we know which steps we need to take in order to solve a problem? So here on this slide you see 4 phases. The first phase is analyze and specification. Understand your problem. If you don't understand what the problem is, it will be very, very difficult to solve it. So if you understand the problem, you go to the next phase and you write an algorithm. You write this series of steps that takes you to solving the problem and a solution. And once you have this algorithm that you typically write down in pseudocode because you're not really coding yet, you're trying to find a solution to a problem. And once you have the solution, you go to the implementation phase. And in the implementation phase, you code it using a real high-level programming language, you compile it, you debug it, execute your program, and test whether it actually does what you want it to do. And finally, when you finish, you go into the maintenance phase where you actually use the solution, document it such that other people can also use it, and improve it if it's necessary. So let's look at the 2 most difficult phases on this slide, which are the first 2. Understand your problem and solve it. So how can you understand a problem? If you get a problem and you need to solve it, ask questions. Ask questions about it. What do I know about this problem? What is the data? What are the inputs that I have in order to get to a solution? What is the data that I can process? What is the information I can get out of this data? And how can I use this information to go to a solution? And what does the solution look like? And are there any sort of special cases? Is the solution maybe obvious in some scenarios and less obvious in the other scenarios? And how do I recognize when I found a solution? And is there a similar problem? It's very important that you don't reinvent the wheel all the time because problems come in different forms. So if we have a problem, first we can see if maybe it's some problem that we already solved before and we can use that solution and we don't have to reinvent the wheel. So to understand something, ask questions. So when we understand what we need to solve, we need to write an algorithm. So to do that, what we can use is a strategy called divide and conquer. We break up a larger problem into smaller units and solve each problem which is smaller by itself. So let's look at an example so it becomes clear what this means. For example, we need to solve a sorting problem. We've got a list of numbers and we want to sort them. So here you see a way of doing this with a divide and conquer strategy. So here on top you see the numbers that we want to sort and we divide. We divide this into two smaller sorting problems. Sort the first 4 numbers and sort the last 4 numbers. And we divide more. Where we have 4, so we say we divide again in 2 and 2. And we divide more, and we divide in 1 and 1. So sorting lists with one element is simple, because it's just that one element. So then we conquer our results. So we say, okay, this one is sorted, that one is sorted, so let's put them together in a sorted way. So 3 is less than 8, so I put 3 before 8. And I do this with all the smaller problems. So 2 is less than 9, 1 is less than 7, and 4 is less than 5. So I've already conquered solutions to smaller problems. So we go on. Now we want to put this one and this one together. So we merge them in a way that they are sorted. So we start, we say, okay, 2 is the smallest here, then comes 3, then comes 8, and then comes 9. So we have this one sorted and that one sorted, and in the last step we have to merge again, and finally, as you see, we've got a sorted list of arrays. So this is how you divide and conquer. In the next section, we'll look more at variables and data types.